Welcome to our lesson on writing algebraic expressions. This lesson is a little bit different than our previous lessons because you will be taking notes without a guided note sheet. So I will help you out by letting you know exactly what you need to write out. Go ahead and take a moment to write out the title here for our notes today, Writing Algebraic Expressions. Okay, go ahead and write out both of these definitions as well as the vocabulary word that goes with it. And while we discuss these vocabulary words, I will be writing out examples that I want you to write as well. Okay, so the first vocabulary word here is variable. As you might know, a variable is a symbol that represents one or more numbers. So, for example, I could say y. The variable y might represent a certain amount of apples. So it could be 5 apples or 10 apples or 11 apples or 2 apples. Because we don't know how much it represents, we're going to assume that it could be various amounts, and we're going to call it a variable. Any letter can be represented as a variable. Okay, the next word here is algebraic expression. Now the word expression is familiar to us. We know that it's a math phrase that doesn't have an equal sign. An algebraic expression is a math phrase that has at least one variable, and again, no equal sign. So an algebraic expression could be something like x minus 10, or it could be something like 8y, or it could be something like 5 divided by s. Any of these types of math phrases have at least one variable in them, so they are considered an algebraic expression. Okay, one thing that we need to be clear about as we move into our algebra unit is the proper way to show that you're multiplying a number with a variable. So let's say that I wanted to show y times 6. Okay, go ahead and write that out, y times 6. There's actually just one way that is a good way to write it, and then there's a couple of bad ways to write it. Let's go through some of the bad ways, the ways that we are not going to be utilizing. I do not want to see a variable and then a times symbol in the number. So not that times symbol, not the dot times symbol. Sorry, this is a little sloppy. I don't want to see a parenthesis. None of those are good ways to show multiplication. I also don't want to see the letter and then the number pushed right up next to it. What I do want to see over here is the number first and then the letter pushed right up next to it. So this says y times 6, and the answer here would be 6y. Now, even though it says y times 6, a lot of people think y needs to come first, but it doesn't because of the commutative property of multiplication. So we know things like 5 times 6 is the same as 6 times 5, or 2 times 3 is the same as 3 times 2. So because you can multiply in any order, that's why we're allowed to put the number first pushed right up next to the variable. So again, no parentheses, no symbols in between. The letter does not come first, it's the number and then the variable. Okay. Write an expression for each phrase, and all you need to do is follow along with me and write out the phrase. You don't need to actually write out these notes. So, the first phrase says, swimming m meters per minute for 3 minutes. When you do this on your own tomorrow during class, I'm going to ask you to annotate each problem. And you can remember from our last unit that annotate means we're going to write little symbols above to help us to create the math problem. So, I know m meters is probably important. I know the number 3 is probably important. Now I need to decide what operation am I adding, subtracting, multiplying, or dividing. It says m meters per minute, and I can remember from that graphic organizer we used, per is a special word. Per can either mean multiply, or in some cases it can mean divide. So we need to think about the situation in order to figure out what per means here. Swimming m meters per minute for 3 minutes. So that would be m meters, m meters, m meters. Because I'm continually adding m meters, that is multiplication in this situation. So what I want to do is write an expression that shows m times 3. And like we learned in our last slide, the proper way to do that is 3m. We don't want to write m3, we don't want to write m times 3, just 3m. Okay, let's go ahead and annotate and look at the next problem. The sum of x and $8. The two numbers that I need are my variable x and my numeric value, 8. And then I'm going to look for a word that might tell me if I'm adding, subtracting, multiplying, or dividing. Luckily, I see the word sum, and I can remember that sum is the answer to an addition problem. So I'm going to be adding x plus 8. And that's it. Those are my algebraic expressions. Okay, now we're going to go ahead and write an expression for these two word phrases. I want you to try this one on your own. Go ahead and write out the expressions that you think would be represented, and then press pause and we'll go over it. Okay, hopefully you got the same answer I did. I see 30 bananas divided by m monkeys. Divided is very obvious to me. I know it's going to be a division symbol. So you could have 30 divided by m. Sorry, can't really see my dots. Okay, 30 divided by m. Now, there is another way to write this that's more of an algebraic way to show division. And that's that fraction bar that we've talked about before, 30 divided by m. So I really like this way of writing it when we're in algebra. And I'm going to encourage you to use that way too, but you can still use our old division symbol as well. Now, one thing I want to point out is that division is not commutative. It does matter what order we're dividing things in. For example, 10 divided by 2 is 5, but 2 divided by 10, that's a decimal. That's 0.2 or 2/10. So the order really matters. So you're going to have to be careful and go in the order that you see the numbers coming in. The last one here, the product of 4 and y. I know 4 and y are my special numbers. Product means multiplication. So 4y. Again, I don't want any multiplication symbol when I have a number and a variable. Okay. This next problem is a little bit tricky because the phrase less than is involved. That's my tricky phrase. I see I have $3 less than Jeremy. I'm going to say that J is Jeremy's money. Okay, this is Jeremy's money. And if I have $3 less than Jeremy, I'm going to draw a picture really quick. What I'm doing is we could pretend this is Jeremy's bag of money, and there's all this money in there. We have no idea how much. But what I know is that I have $3 less than Jeremy. So what I would do is I would start with Jeremy's money and I would take away 3 because I am 3 less. So because I have to start with Jeremy's money, J, and then take away 3, that's my actual final answer right there. That's my algebraic expression. So go ahead and make sure you have all of that written out, the picture and the information. 3 less than Jeremy. Again, it's tricky because it's not 3 minus J, it's actually J minus 3. Now, every time that you see less than, the order kind of flips around. And I want you to go ahead and write out what you think. Why would the phrase less than, why does the order kind of flip around? And we're going to go over this tomorrow, so make sure you have a sentence or two. If you need to pause the video, go ahead. Okay, next question. Again, you don't need to write out the problem, but you'll write out what I'm writing as you write with me. A club at school is making posters. The materials for each poster cost $4. Write an expression for the cost of P posters. So I'm going to go ahead and scan the problem. I see 4 is important. I see P posters is important. The club is making posters. The materials for each poster cost $4. Now, if you look back at your graphic organizer from a few weeks ago, you'll see that each means multiplication because this poster costs $4, this poster costs $4, this poster costs $4, and so on. We don't know how many posters we have, but we know that each one costs 4, which is multiplication. So the way to show 4 times P is 4P, and that's my final answer. Okay, next problem. This gets a little tricky because there's a lot of different answers that you could have. Write 3 different word phrases for x plus 2. Well, the most obvious one is x plus 2. That's a word phrase. Another way that I could say this is x increased by 2, because we know if we increase something, we're adding. So x increased by 2. Another way I could say this, I see that we're adding them, so I could say the sum of x and 2. Now, there's a lot of different ways that you could do this, but those are just some of them. So go ahead and make sure you have those written out, and then let's go ahead and have you try the next problem on your own. Go ahead and write 3 different word phrases for this particular problem. Press pause, and then I'll go over a bunch of examples. All right, now if your examples don't match mine exactly, that's okay. But one thing that you could say is C minus 50. That's one. That's the most basic option. You could also say the difference between C and 50, or the difference of C and 50. The difference between C and 50. And the reason that that's an acceptable answer is because difference means the answer to a subtraction problem. Another thing that you could say is 50 less than C. Another thing you could have is C decreased by 50. And again, there's a lot of different answers you could have here. So anything that you have is different than mine could still be correct. All right, and our last slide is a set of rules, and I want you to go ahead and write out this set of rules. It says the order for subtracting and dividing is important. Remember that subtraction and division are not commutative. So always use the order you see except for the phrase less than. Okay, so go ahead and write that out. The other rule I want you to write out and remember is that for multiplication, we write the number and then the variable. So for example, 5x or 3y or 2c. All right, that's it for tonight. Have a great night. Thanks for watching.